Hey guys, I want to do a video that is evaluating composite trig functions. So trig functions inside of trig functions, and how do we evaluate stuff like that. So we're going to take a look at this example, and we have that cos of 2 sine inverse of 3 over 5. So generally it's the same procedure for most of these problems, and you start off by taking whatever function is on the inside usually and setting it equal to a variable if we can't evaluate it directly. So in this case it's usually going to be an inverse function. Some sort of inverse is the one that we're setting equal to a variable. So we'll take sine inverse of 3 over 5 and we will set it equal to a variable. Let's choose theta for our example. And if we take the sine of both sides, sine and sine inverse will cancel out, leaving us with 3 over 5 is equal to sine of theta. And we know that sine of theta is equal to the opposite over the hypotenuse. So we can draw a triangle, a right angled triangle, and choose one of these values, one of these angles to be theta. Completely arbitrary here. And we know that the opposite side of that theta has to be 3, and the hypotenuse will be 5. So using either Pythagorean theorem or just knowing that this is going to be a 3, 4, 5 triangle, you can find that the adjacent side must be 4. So let's rewrite what we have, or what we're trying to evaluate. It's the cosine of 2 times, and remember we made that substitution, that inverse function there is going to be theta. So we're trying to evaluate cosine of 2 theta, and we've come up with a relationship with a right angled triangle in terms of theta. So we'd like to eliminate that 2 theta by using some sort of trig function or some trig identity. So you might remember that cosine of 2 theta is equal to cos squared of theta minus sine squared of theta. Right? So really what this is just cosine of theta squared minus sine of theta squared. And we can tell from our triangle what both those values will be. Cosine of theta will be the adjacent over the hypotenuse, so 4 over 5 squared. And then the sine of theta we've already determined to be 3 over 5. So this will be 3 over 5 squared. And now it's simply just math and evaluating this, and we'll have 16 minus 9 over 25, which will reduce to 7 over 25. And that's the exact form of our final answer. So let's move to another example. This one is to evaluate the cotangent of the arcsecant of cosecant 5 pi on 4. And like I said before, it's going to be a similar procedure, except typically we set equal to the variable, like one of the inverse functions. But the reason that we're not going to do that right away here is because cosecant of 5 pi on 4, we can actually just evaluate that right away. So let's take a look at what that would be. And I know that 5 pi on 4 is in the third quadrant, which is right here. Great. And it's going to be making an angle of pi on 4 with the x-axis, which means that I know that this is going to be 1, 1, and square root of 2. And I know that just from the special triangle of pi on 4, right? Great. So the cosecant of 5 pi on 4, cosecant of 5 pi over 4, if we know that's the inverse sine, and sine is opposite over hypotenuse, then this will be equal to the hypotenuse over the opposite, which will be equal to the square root of 2 over 1. And remember, since we're talking about 1 over sine here, and sine is negative in the third quadrant, this is negative square root 2. Don't forget that. So now what we've got here is cotangent of the arcsecant of and negative square root 2. Great. And we're trying to evaluate this. So now we've got something similar to the first example, and we're going to let that inverse function on the inside be equal to a variable. Let's choose theta. So we have secant inverse of negative square root 2 equals theta. Taking the secant of both sides, we have negative square root of 2 equals secant theta. Great. So now let's take a look at this. Let's draw out our cast rule. Okay. And we know that we're working with a negative value of secant. And secant is just 1 over cos, which means that our cosine is going to be negative. So it can't be in the fourth quadrant. It's definitely not going to be in the first quadrant where all of the values are positive. So it's either going to be in the second or the third quadrant. So what we need to remember here is that we were taking the secant inverse of negative square root of 2, and the range of arcsecant is between 0 and 2 pi. So because of this, we know that it's not going to be in the third quadrant either. So our value is going to be in the second quadrant. Great. So now that we've determined this, let's draw out our triangle similarly to the first question. And we'll choose an arbitrary side to be equal to theta. And we know that secant is going to be equal to the hypotenuse over the adjacent. Because cosine is adjacent over hypotenuse, the inverse will be hypotenuse over adjacent. So the hypotenuse in this case will be square root of 2. And the opposite sides must be 1 and 1. Great. Okay. Solid. So now let's rewrite this again. We know that what we're trying to evaluate is cotangent of, and we said that secant inverse of negative square root 2 is going to be theta. So we're trying to evaluate the cotangent of theta here. And the cotangent of theta is going to be the adjacent side over the opposite side, correct? So from our triangle that we've just drawn, we know that the adjacent to theta is 1 and the opposite is also 1. So it's a value of 1. And now we just need to determine, is this going to be positive or negative? And we know that we're in the second quadrant here, and the second quadrant tangent will be negative. So our answer here should be -1. And that is the final answer to the second question.